Hello everyone. Today we're going to be talking about derivatives for the first time. So if you remember from before, we defined the slope of the tangent line, the instantaneous rate of change, and the instantaneous velocity of an object at x equals a. And it all required us to compute the following limit. So let's write down that limit right now. So we'll see this limit quite often. So it'll look like this. So we've seen this limit quite a few times, or at least not even in this form. Well, it can be in this form, but we've seen this main limit right here a lot. And we're going to continue to see it quite a decent amount. And we could actually rearrange this, and we can get the definition for finding a derivative. So if we change the notation slightly, it'll look like this. The limit as h approaches 0 of x plus h minus f of x divided by h. And this is the definition for our derivatives. I guess for derivatives. And basically this is going to help us find the slope of the tangent line. The slope of the tangent line, the instantaneous rate of change, and the instantaneous velocity of an object at x equals a. It's all actually just this limit right here. So we can find all the following things using this limit. And we're actually going to be using this limit today in order to solve a few examples. So let's basically write this down as a definition. So we'll say f prime of x, which is basically the derivative of f of x, is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. So basically, what this is saying essentially is the derivative of f of x with respect to x is the function f prime of x, and it is defined by the following: by finding the slope of the tangent line at that given point. But this is and we can find our derivative with this. Let's take a look at a few problems where we can actually use this equation. We'll go with example 1. Find f prime of x, and f of x will be equal to 2x squared 16 plus 35. Now try to do this in your head, or not try to do this in your head, but try to do this on your own and see if you could possibly get, see if you could possibly get the answer just by the definitions that I was able to give you initially from before. So the first thing we have to find, we'll put this in, I guess, blue. We have to find f of x plus h. but f of x plus h is literally just going to be 2x plus h squared minus 16 plus 35. And we can say x plus h times x plus h is going to be x squared. You could just really just do it in your head. X squared plus hx, which is just going to be plus 2hx plus h squared minus 16, minus 16x, whoops. We got to put in the x value right here. And this is real x. That wouldn't make any sense if it was just minus 16 plus 35. Anyways, and then it's going to be minus 16x, I guess minus 16h plus 35. And then we are given 2x squared plus 4hx plus h squared minus 16x minus 16h plus 35. And now we have to add that to or like not add that, but like have this subtract f of x. So let's remove all of this now. Just move this. Do that, and then jeez. Then we can say minus f of x, which is just going to be 2x squared minus 16x plus 35 divided by h. And this may look a little bit intimidating because, well, I mean, there's a lot of numbers. But usually the way these questions are structured, you could just get rid of a lot of these numbers off rip. So we see negative 2x squared. We can ignore 4hx, negative 16x. Oh, or I think they're supposed to be positive. 16x. Oh, yeah, no, this was supposed to be, okay, whoops. Minus 2x squared plus 16 minus 35. Whoops. You got to remember when you're putting negative, you have to change the sign of every single number, which I, of course, didn't do. Now we have 35. We can get rid of that. And we're left with 4hx, h squared, and negative 16h. So it's going to look like, let's just remove this. Could write down number, which is 4hx plus 2h squared minus 16h. And based off this, and we see we have to have the limit as h approaches 0. So inevitably, once we break this down enough, then we substitute h for 0. And we can see right here that we can actually get rid of h, like at least as many as we can, by just, well, dividing out. I will just remove this off for now. So now our f prime of x is going to be looking like x plus 2h minus 16. Since we divided out the h, we're going to be left with this. And since we've broke it down pretty much as we possibly can, we can just get rid of the h, and we could say 4x minus 16. And since we've already done this, this is really all that we're gonna be left with. So our answer for f prime of x is gonna be 4x minus 16. And that's how we were able to do it through the definition that I gave you guys earlier. Let's do another example. Maybe something that looks a little more different. We'll say example 2, find g prime of x. And we'll say g of x is equal to say x over x plus 1. And now we're given a fraction, and we're going to have to do g of x plus h minus g of x divided by h. So maybe take a crack at this, see if you can, you think you can do it, try it out if you can, or at least if you think you can. And yeah. All right, so let's go ahead and solve this. So we're going to remember our definition as h approaches 0 of, I guess in this case, g of x plus h minus g of x divided by h. So we just need to find our g of x plus h in order to get our derivative. So for g of x plus h, it's going to, or at least for the entire fraction, it's going to look like this. It's going to be x, or just x plus h divided by x plus h plus 1 minus x divided by x plus 1. Because you got to remember f of x plus h minus f of x. In this case being g of x and g of x plus h. And then we'll divide this out by h. So the first thing we have to do is take out this h. So we have to make it 1 over h. And we have to remember the limit as h approaches 0. So this right here is going to look like x, x plus h times x plus 1 minus x times x plus h plus 1 divided by, because we have to basically multiply both x plus h plus 1 by x and x plus 1 by x plus h. So that's why it looks like that. And then it'll just be x plus h plus 1, just the denominators, and x plus 1. We'll just take this out for now. All right, now from here, it's going to look like x squared plus x plus xh plus h minus, I guess, x squared plus xh plus x. divided by same thing. So we're just gonna take this and put it right here. We're not gonna multiply the denominator. I mean, at least we're not gonna really. We're just gonna leave it as is for now. We'll just focus on the numerator, and it'll be x squared plus xh plus h minus x squared plus xh plus x. And as we can see, there are some common, I believe, um, coefficients, not coefficients, but like just common like uh, numbers we see. X squared, negative x squared, x plus xh is here, and so is x. So all that's really left in the numerator is h. So we're going to, actually we're going to change this entire fraction. So now it's going to look like the limit as h approaches 0 of 1 over h times h divided by t plus h plus 1, t plus h plus 1, and t plus 1. And as we can see, we can just get rid of h right here. And so now we're just left with I guess 1 divided by t plus h plus 1 times t plus 1. But remember, now we can substitute h for 0 because there's no really underlying problem that occurs. T, oh no, that's weird. I meant x, sorry. X plus h plus 1. I did it with t in my notebook. So now, since we can substitute h for 0, we're going to be left with 1 over x plus 1 times x plus 1 equaling to 1 over x plus 1 squared. And that will be our derivative for g of x, or we can say this will be g prime of x. It's a little bit of a hassle doing it from the limit definition each time, and we're going to find out other ways that we can integrate it. But for now, we're going to stick with this because it's the most basic form of solving a derivative, or solving for a derivative at least. We're going to do one more example, and then we're going to go over 2 definitions. So we're given our 3rd example, I believe, and we're told to find j prime of x. J of x is going to be equal to the square root of 5x minus 8. Let me just read 5x minus 8. There you go. That looks better. So try to I guess find the derivative for this. Now let's go ahead and try to find the j of x plus h value. At least in this case, it would just be 5x plus h minus 8, square root of that. So we'll just do the entire limit. Divide that by h. Yeah, so basically what we're going to have to do for this problem specifically is we're going to multiply the, I guess, both the top and the bottom of this fraction both the numerator and the denominator by a rationalized number. So it's basically going to look like this right here. X minus 8 divided by basically the same thing. It's just going to be 5 of x plus h minus 8 plus the square root of 5x minus 8. And yeah, so we'll just multiply these two together. So let's just open up some room first. It's going to end up looking like 5x plus 5h minus 8 plus 5x plus 8 h times our denominator from the, so it'll just be square root of 5x plus h minus 8 minus, or at least plus in this case because it's a rational number, 5x minus 8. And looking at this here, we can already get rid of a few numbers. So we'll just be left with 5h. But we can also get rid of the h, so it would just give us this number right here. Oh, whoops. Just plus 5h minus 8. We're going to extend it out now because we're going to probably use it as h approaches 0. So just 5x minus 8. So we're just going to plug in h for 0, and we're going to be able to get rid of this h right here. And because of that, we're going to be able to write down our, I guess, our answer for the limit before, and we can say 5 over 5x minus 8 plus 5x minus 8, which will just be equal to 5x minus 8. And that will be our final solution for j prime of x. This is what j prime of x would be equal to. And the examples that I kind of threw at you weren't really too bad. It's just kind of finding f of x plus h, plugging it back into the original formula, and just kind of solving from there, and trying to break it down as much as you possibly can before you end up substituting h for 0. Um, so we're done for the examples, but I just wanted to write down a definition and a theorem, and also some common notations for derivatives as well. So we say f of x is differentiable, or at least we call it differentiable, at x equals a if f prime of a exists and f of x is called differentiable in an interval, the derivative exists for each point that interval. Okay, so f of x is differentiable at x equals a. Um, if f of a exists and if f of x is called differentiable, and f of x is called differentiable on an interval if the derivative exists for each point on that interval. So yeah, it's basically, it kind of says what it means. So we can call f of x differentiable at x equals a if a derivative for it, while you could also plug in uh I guess a for x exists and f of x is called differentiable on an interval if the derivative exists for each point on that interval. Because you need the derivative in order for it to be differentiable. So I just wanted to, you know, just put that in there because later on you might do differential equations, and this would technically be the beginning to I guess learning the basics before learning something like I guess differential equations. So, and also we're gonna go over a theorem. So we'll say f of x is differentiable x equals a, or we'll say if f of x is differentiable at x equals a, then f of x is continuous at x equals a. So so basically f of x, we'll read it one more time. If f of x is differentiable at x equals a, then f of x is continuous at x equals a. So that's basically what it means. So um, if we can find a derivative for a function, then that function has to be continuous. That's basically what that means. Here are a few different, like, I guess, notation styles of meaning f of prime of x notations. So of course there's f prime of x, but there's also d of over d of x of f of x. There's I guess y prime. There's f prime of x, as we already talked about, dy over dx, and d over d of x of y. These just look like rearranged, versions of the same thing, but these all technically mean the same exact thing, which is um the derivative of f of x or y or whatever function you want to name it as, whether it be g, not h, f, g, l, a, like really anything. And it'll basically all of this is just means the same exact thing. If you were to see another, like if it was g instead, it would be dg over dx. As we saw before, it said g of x. But yeah, these all just mean the same thing. And yeah, this is the intro to derivatives. And a lot of what we're going to be doing from here on out, and especially in the future in Calc 2, uses a lot of derivative stuff. So the slope of the tangent line means a lot in, I guess, future mathematics, short from here. So yeah, this is just a brief introduction to derivatives and how we can solve them using the default um, tangent line limit, how we could solve it using that. And yeah, I'll see you guys for next video.